Alright, so let's do exercise 3. Mr. Goowanter, whose mass is 60 kilograms, is doing a physics demonstration in the front of the classroom. Okay. Let's just straight up highlight right now his mass. 60 kilograms. That tells me he's going to be in probably every problem if we have to do multiple problems. A, how much gravitational force does he exert on Martha in the front row? Martha's mass is this. So now all we're lacking in our formula is distance. Awesome, right there. She's in the front row. Her distance is 1.5 meters away. Cool. 1.5 meters. And then looking at B, how does that compare to what he exerts on Lester, who is 65 kilograms? Way in the back row, and he is 4 meters away. Okay, cool. So again, we got one of those where we got to compare, right? Compare. That means we're going to have to do it twice. So first thing I always do, let's readjust this a little bit. There we go. We got some leftovers. There we go. Alright, so first thing we need to do is we need to write down our formula. Okay? So, our formula is, if you remember this, there we go. Now we're perfect. Force of gravity equals gravitational constant times the mass 1 times the mass 2 over distance squared. Alright, so we're going to do this twice. So I'm going to try to break it up like this. Okay? So, force of gravity. First, let's do Martha. Equals gravitational constant, which is 6.67 times 10 to the minus 11, times Martha's mass. Actually, let's do the constant mass first. Mr. Goowanter's mass times Martha's mass, which is 55. Over the distance squared, and the distance is 1.5 meters squared. Awesome. So, you know what? We're pretty set up, so let's do this. So this is Martha. Martha. Save Martha. And let's do Lester. So, force of gravity between the teacher and Lester equals the gravitational constant, 6.67 times 10 to the minus 11, times our professor's weight of 60 kilograms, times Lester's weight of 65 kilograms, divided by the distance, in this case it's 4 meters, squared. Okay? So, I'll give you guys a second to calculate this, and I'll calculate it myself. Alright, so hopefully you did that. So let's do question A. Or let's do letter A. How much gravitational force, this, did he exert on Martha, who was in the front row? So we do the gravitational constant times the first mass times the second mass, which is there, divided by the distance squared. And you should have gotten 9.78 times 10 to the minus 8, and then it's a force, so we know it is newtons. Cool. Good. So that was this one. How much does this compare? So we know we're going to have to find the difference between what he exerts on Lester. Okay? So Lester's, we did the gravitational constant times the professor's mass times Lester's mass divided by the distance, which is 4 meters squared, which that's going to be 16, right? 4 times 4. So Lester's force equals 1.63 times 10 to the minus 8, and it's in newtons. Therefore, how does that compare? Well, it looks like Martha has a larger force than Lester, which makes sense because Lester is quite a bit further away. Even if his mass is greater, 65 compared to 55, his distance makes that gravitational force, if this is our graph, it makes it drop off a lot. Bam. Plummet, right? That's why, if you compare his is way, way down. Martha equals much higher. Lester equals much lower. There we go. Exercise 3, complete. Success.